And then we're just going to kind of briefly go through the rest of the groups. This group, not too significant. We have nitrogen on the top of this group. Again, anything in a group, though, they're all going to behave similar. So everybody underneath nitrogen is going to behave similar to nitrogen, so forth and so on. Again, this is your nitrogen group. Non-metals, you have a mixture of non-metals, metalloids, and metal actually in this group. Again, group 16 is similar to nitrogen. You have some non-metals, and we have, more importantly, we have oxygen as the head of the group. Okay, he is reactive, oxidation value of -2, meaning he wants to gain 2 electrons, and I have said before, oxygen's pretty nasty. He will steal electrons from a kitten. He really wants those 2 electrons. All right. Most elements with atomic numbers greater than 83 are radioactive. Feel free to sing the song, radioactive. Meaning they experience radioactive decay. More on that later in the spring. Halogens, group 17. They are in this group. What they have in common is they have 7 valence electrons. 7 is pretty close to 8. They only need 1 more electron, okay? So they very much would like to get an electron from someone who wants to lose an electron. And ironically enough, who wants to lose 1 electron are the group 1s. So the group 1s you guys are going to start to see really want to pair up with the group 17s, these halogens, because the group 1s have an electron that the halogens want. So it's a match made in heaven. So here's your halogens. Your elements that go with this, they react readily with metals to form your ions. So they're going to react with your group 1 to form ions with a -1 charge. So notably, your chlorine sitting there at number 17, he's going to hook up with sodium, number 11, and they're going to form the salt that you put on your French fries. Okay, it's interesting also to kind of look at this. These guys are non-metals, folks. So fluorine is a pale yellow gas in real elemental form. Chlorine, the chlorine used in warfare, greenish yellow gas, that's poisonous. Bromine's a red-brown liquid, and iodine is that black solid. You probably have seen iodine solution that you put on your cuts, maybe, or Benadine solution that we use to scrub cuts. It's got like that dark brown color to it. But elemental iodine is a black solid. What's really kind of cool is iodine sublimes into these beautiful clouds of like purpley gas. And sublimation is just going from a solid straight to a gas, and it's really actually a beautiful sight. Slightly poisonous, but a beautiful sight. Okay. Salts. So the salts that are formed from these halides, these halogens mixing with the group 1s form salts, okay? The salt that you guys are commonly experience on a day-to-day basis, your salt you put on your French fries, that's sodium chloride. That's one salt, but believe it or not, there's other different types of salts out there in the world. Not all are edible, though. So anytime you have the halogens mixing with the metals, we form these salts called halides. Okay, they're all nonmetals. All the halides are nonmetals. They're highly reactive. The halogens, and they form diatomic molecules or compounds in nature. They're never found by themselves. So chlorine gas, it's never found by itself. Chlorine is found hooked on to another element as a compound, not as a single element, okay, because they're just not stable enough. All right, noble gases. This is what we've talked about. The noble gases, group 18, the ones that have achieved nobility. How did they achieve nobility? They have a full valence electron shell, okay, meaning they have the great number 8. 8 is great in chemistry. And they have a completely filled outside shell, which means they do not want to combine with any of the other elements on the table. They don't need to. They don't need to gain electrons. They don't need to lose electrons. They have everything they need right there, okay? And all of your other elements want to achieve their electron configuration. By doing so, they will achieve the same balance that the noble gases have just naturally. So for example, chlorine that's sitting so close to argon over there, he wants to gain an electron to have the electron configuration like argon. That's the goal, okay? Sodium, for example, wants to lose an electron and have an electron configuration like neon, because neon, like all the other noble gases, have 8 electrons in its outside shell. Okay, so your noble gases, keyword there, they're gases. Okay, they're all going to be gases. They are all noble gases, meaning they've achieved nobility by having a full valence electron shell. They're monoatomic, meaning they do not combine with anything else, and they don't combine with another atom of itself either. So they stay by themselves. They're unreactive. They don't react. You can't set them on fire. They don't explode. All right, helium birthday balloons, if you put a match to it, it's not going to do anything. If I filled a balloon up with hydrogen, it's going to explode. Okay, so that's the difference between a non-reactive gas and a reactive gas. So hydrogen being in group 1 is very hostile versus your group 18s have a valence electron shell, are not going to do anything. Okay, these are what we call inert gases. They don't react with anything. So argon and krypton, for example, these are the gases that I told you can be found in between the panes of your window. If you take a look at your windows at home, you can't see the gas, you can't smell it, but just take my word for it that one of these gases, chances are it's argon or krypton, is going to be found in between the window panes of your windows at home, and that's used to insulate the windows to keep the heat in or out depending on the situation, but it's to help to not transfer the heat and to, keep also a little bit of a sound barrier as well. So that gas is there for that reason. Okay, again, cold inert gases, just kind of know that word in case they throw that at you. And that would be your noble gases. Okay, transition metals, these are the ones in the middle. Transition meaning that they do have some changes going on. These are hard solids with high melting points. These are the common ones that you guys are used to seeing. Let's just go back and take a look. You have copper on there. You have zinc. You may have heard of those two metals before, possibly. Titanium, sure. You have silver. Okay, platinum. Gold is a big one there. Okay, so these guys, these are your metals, again, that you're used to probably hearing by themselves found. They are, again, hard solids with high melting points. They have multiple oxidation states. So they do have some transition going on, meaning that they tend to lose a different amount of electrons depending on their, let's just say, situation, okay? They tend to be less reactive, all right? So again, these are things that you've heard of before. Silver, okay? It's not going to explode in your hand. It's not going to do anything weird. It's less reactive, okay? These guys will form ions that have a color, either in an emission spectrum, which we talked about, or simply just in solution. So what's interesting to note is if they're talking about a substance that produces a color, they're probably talking about one of these transition metals. Okay, so which of the following elements could form a colored solution? So see if you could figure out who that would be. So your question basically is, which one is the transition metal? Okay, that's really what they're asking you. Okay. And you should have got cobalt for that one. So just double check and make sure you have capital C, lowercase o, and you see why that is. So if you go back, we should see that cobalt is in this position. Let's just go back to that slide, please. Okay. And if you find where CO is, you'll see that he's right there, number 27. Okay, so you should notice that in addition to cobalt, there's another transition metal sitting here. So who could it be? So if we go back to that slide, here's cobalt. Who else is over here in the transition metal area by cobalt? And it looks like if we look next door, we have Fe. Fe is iron. So iron too would be a choice for this question. So they both would be elements that would form a colored solution. Both Fe, iron, and cobalt. The other two are not. The F is fluorine. If we just take a look, fluorine nonmetal. And the last one was Sr, And this is a metal, but it's not a transition metal. So only the ones in this section here, those are your transition metals. And they're going to form your colored solutions. Alrighty.